Hey, seventh grade. Today we'll be working on 2.5, which is solving equations containing integers. I'm going to try the notes a little bit different today. I'm just going to use the same note sheet that you have. Hopefully, our will just match up a little bit better than because sometimes in the PowerPoint they don't quite match up. So hopefully this will solve that. If you like this or don't like this way of doing it, please feel free to let me know. I'll always take some feedback. So today our lesson objective is to be able to solve one-step equations, and now we're going to add integers. So I know last year you had talked about solving one-step equations, but now we're going to add integers. So essentially we're going to add negative numbers is the new step that we're adding this year in seventh grade. Okay, if you remember from solving one-step equations, what you're trying to do is isolate your variable. In other words, you want at the end to say x equals whatever, okay? Maybe 5, or you're trying to solve for your variable. And to isolate it, remember, you need to either add or subtract, or sometimes it's multiply or divide something to both sides of your equation. Remember, equations are like scales, okay? And to balance out a scale, you need to either add the same weight to both sides or subtract or multiply or divide or whatever you're doing, right? So let's take a look at example 1 and see if this brings back a few steps. It says negative 6 plus x equals negative 7. So we're looking for what number that when you add negative 6 to it gives you negative 7. Okay, the other way is I like to split my equation at the equal sign. So I've got a left-hand side and a right-hand side. And again, I'm trying to isolate x. So I'm trying to get x all alone on the left-hand side. So I need to move my negative 6 to the other side of the equation. Okay, to undo that negative 6, I need to add 6. And when I add 6 to the left side, I have to add 6 to the right side to keep my equation balanced. Okay, so add 6 to both sides to isolate the variable, because negative 6 plus 6 cancels out, that's 0. And now the only thing I have on my left-hand side is x, which is exactly what I want. And then the only step I have left is to take negative 7 and add 6, which would give me negative 1. Okay, remember, if you're still a little bit confused on that, it's like saying you have 7 negatives, 3, 4, 5, 6, 7, and 6 positives, 2, 3, 4, 5, 6. Okay, 1 positive and 1 negative will cancel each other out, and you're just left with 1 negative, which is what we came up with. So in the end, negative 6 plus negative 1 gives us negative 7. Let's look at letter B. It says P plus 5 equals negative 3. So what number, when we add 5 to it, would give us negative 3? Again, I think it's helpful to split my equation at the equal sign. On the left-hand side, I need to get rid of this plus 5 because that's in the way of isolating or getting P all alone. So the opposite of adding 5 would be subtracting 5 to both sides of my equation. Okay, or same thing as adding negative 5 to both sides to isolate the variable, get P all alone, because 5 plus negative 5 or 5 minus 5 cancels out. I'm just left with P. P equals, now I just have a little math to do, negative 3 plus negative 5. All right, same sign, keep the sign. Okay, so that would be negative, and then just add. So 3 plus 5 would be 8. So negative 8 would be our answer. Let's check that. Does negative 8 plus 5 equal negative 3? Yes, definitely does. Okay. So that's what the first two look like? Let's scroll down a little bit so I can see letter C here. And then example 2 as well. All right. So letter C says y minus 9 equals negative 40. So the question I'm asking myself is, what number, when I subtract 9, gives me negative 40? All right, so I'm trying to isolate my variable. I see y is being subtracted by 9. The opposite of that is adding 9. So plus 9, add 9 to both sides to, once again, isolate my variable. Because negative 9 plus 9 is 0, then I'm just left with y equals, and then I have negative 40 plus 9. Okay, different signs subtract. So 40 minus 9 would be 31. And then I take the sign of the number with the greater absolute value. Greater absolute value would be here, so I'd take the negative sign. So negative 31 would be my answer. Okay, hopefully you're starting to catch on a little bit. Let's look at example 2 where we now have a division problem. It says b divided by negative 5 equals 6. So what number divided by negative 5 would give us 6? Okay, so again, we're looking at what is being done to my variable and how can I undo that? Well, b is being divided by negative 5, so the inverse of that would be to multiply by negative 5. Okay, multiply by negative 5. And if I do that on the left-hand side of my equation, I have to do that on the right-hand side as well. Okay, so I'm multiplying both sides by negative 5. Okay, well, dividing by negative 5 and multiplying by negative 5 are inverse of each other. They cancel out. And I'd be left with b equals negative 5 times 6. Well, they have, remember, for our rules for multiplying and dividing is same sign positive, different sign negative. So this would be a negative 30. Okay. You might ask in this first step, why does, when we multiply by negative 5, why does that cancel out? Okay, well, if you think about it, if you're multiplying by negative 5, remember when you multiply by fractions, and if this is a whole number, you can make it a fraction by putting 1 underneath. Okay, so if I multiply it across, I'd have, this would give me negative 5b over 1 times negative 5 is negative 5. Well, anything divided by itself is 1, which is great because that's what I want. I want 1b. I want to know how much 1b is worth. Okay, so that's why when you multiply by negative 5, it cancels it out and you can isolate your variable there. Okay, let's try another one for letter B here quickly. It says negative 400 equals 8y. All right, and the question I'm asking myself is, what is being done to my variable and how can I undo that? Well, it looks like my variable is being multiplied by 8. So to undo that, I would divide by 8. And whatever I do on one side, I need to do on the other. So divide by 8 here. This is just, it looks like a fraction, but again, you can write that division bar, and that means divide by 8. And I'll do that on both sides. So divide by 8. I'll include that in my box here. 8 divided by 8 is 1, 1y, perfect, equals, well, 8 at negative 400 divided by 8. Okay, I have a positive divided by negative, different signs. I'm going to have a negative answer. And 8 goes into 40 5 times, and add that 0 that is left, so negative 50. And does that make sense? If I were to take this value and substitute it back into my original equation, does 8 times negative 50 give me negative 400? Definitely. Okay, so I know I solved that one right. Let's go on to the last example. All right, so picking up on example 3, it says in 2007, a manufacturer made a profit of $300 million. Wow, I would like to make that profit. This amount was $100 million more than the profit in 2006. Wow, incredible. What was the profit in 2006? All right, so first let's identify what some of our variables should be. So it says let P represent the profit in 2006 in millions of dollars. Okay, so the profit in 2007 is equal to P profit in 2006 plus, okay, and that was plus 100 million more. Okay, so the profit in 2007 is equal to, well, it told us in the problem, it was 2007 profit was 300 million. Okay, so if we took our profit P plus 100 to give us a total of 300, we could figure out what the profit was in 2006. Okay, so here's my equation that I'm going to use. P plus 100 is equal to 300, right? This equation right here. Okay, and what I need to do is I need to start by asking myself, how do I isolate P? How do I get that all alone? Well, I see it's being added by 100, so the opposite would be to subtract 100 on both sides of my equation. So that would leave me, I'll do it over here too, subtract 100, and P would equal 300 minus 100 would give us 200. So the profit in 2006 was 200 million. And you can kind of tell that by just reading the problem. You know, it was in 07, it was 300 mil, and it was 1 million more than 2006. So in 06, essentially it was $1 million less than it was in 07. So a million less than that would be 200 million. Same thing we got here. We just put it into a nice, neat equation. Okay. So lastly, I'll have you pause the video and do the check it out problems here. Just 1 and 2 is all I'll ask that you do. See if you come up with the right answer. And if you have more questions, as always, come see me. Okay, to wrap it up for the check it out, let's use purple here. It says y minus 7 is equal to negative 34. I need to isolate my variable. Right now it's being subtracted by 7. So to undo that, I will add 7 to both sides. Negative 7 plus 7 is 0. I'll be left with y equals negative 34 plus 7. Okay, my adding integers rules, they have different signs, so I'll find the difference. 34 minus 7, the difference between those two would be 27. And then take the sign that has the greater absolute value. Well, negative 34 has the greater absolute value, so take that negative sign. So y equals negative 27. And the last one, again, what is being done to my variable? Well, it's being divided by 4. So the opposite would be to multiply by 4 on both sides of my equation. Well, again, you learned before that multiplying by 4 and dividing by 4 are opposites. They cancel out to get 1c equals, I have different signs. So when I'm multiplying or dividing, different signs will give me a negative answer. And 24 times 4, 24 times 4 will give me 4 times 4 is 16. Carry my 1, 8, 9. Negative 96. Okay. So hopefully the one-step equation was a little bit of review, and we just added integers to spice it up a little bit. As always, please come see me if you're still not quite getting it. and good luck on your homework. And until next time.